Okay, this last one, a bit of a doozy. Kind of a two-parter here. We're going to look at the number of silicon atoms in 180 grams of silicon dioxide and the number of oxygen atoms in 180 grams of silicon dioxide. So, first thing I'm going to do is start with the amount that I'm given in the problem, 180 decimal point grams silicon dioxide. I'm going to multiply that by a conversion factor, grams on the bottom for it to cancel out, moles on top. I know from the previous problem that 1 mole of silicon dioxide is equal to 60.084 grams of silicon dioxide. Okay, now my next step is to cancel out moles SiO2 and convert to moles of Si. Now here's where it's going to be really important for you to be comfortable with your nomenclature. Recognize that for every 1 mole of SiO2, there is 1 mole of silicon. Think about this one molecule of SiO2. In that one molecule, there's 1 atom of Si. So if I had 1 mole of silicon dioxide, I'll have the same number of moles of silicon. Then I can simply convert from moles of silicon to atoms of silicon using Avogadro's number. Now, before I solve, I'm going to set up my series of conversion factors for the number of oxygen atoms in 180 grams of silicon dioxide. The first step is going to be the same. Converting our grams of silicon dioxide to moles of silicon dioxide. Now watch what I do with the second conversion factor. I'm still going to put moles of silicon dioxide on the bottom to get that unit to cancel out. But when I think about moles of oxygen, come back to this representation of SiO2. For every one of these, there are 2 oxygen. So for every 1 mole of SiO2, I'm going to get 2 moles of oxygen. And then to finish the conversion, we're going to go from moles of oxygen to atoms of oxygen. And again, I'll use Avogadro's number. All right, now let me come back to the top. I'm going to solve for atoms of silicon using my calculator. 180 times 1, enter, divided by 60.084, enter. I have about 3 moles of silicon dioxide. I'm going to multiply by 1, divide by 1. Now, many of you may think that that is a ridiculous step. Anything times 1 divided by 1 is just going to be itself. However, that's an important step because we get our units to cancel out. Final step, multiply that by Avogadro's number, 6.2, second E, 23, close parentheses, answer. So my number of atoms of silicon, 1.80 times 10 to the 24 atoms silicon. Boom. Now, if I come and do that down here with oxygen, it's going to be 180 times 1, enter, divided by 60.084, enter. Again, 3 moles of silicon dioxide. Notice though, this time we're going to multiply by 2 because now we're talking about oxygen. Then divide by 1 and finally multiply by Avogadro's number. 6.02, second E, 23, close parentheses, enter. We end up with 3.61 times 10 to the 24 atoms of oxygen. Boom. Now, before we go, I want you to stop and think about how does the number of atoms of oxygen compare to the number of atoms of silicon? You should recognize that there are twice the number of atoms of oxygen as there are silicon. Because if I come back to my original representation of silicon dioxide, for every 1 silicon, there are 2 oxygens. And we are done!